All right, so I'm going to do something to help you with your project a little bit. Be up to you whether you watch the movie, but I drew a tree, and I'm going to write some equations for this tree. A tree is kind of nice in that there's some stuff that you can do next 6 weeks. Like this could be thought of as a rotated parabola. It could also be thought of as part of a circle, which is probably how I'll attack it today. But we're going to start off by writing the equation for this hyperbola. And then I'm going to go into Desmos, and I'm going to actually graph it on Desmos. So this is a hyperbola, and I'm just kind of eyeballing it real quick. But I would dare say that's the center of the hyperbola. Let me do some quick counting here. 5, 10, 15, 20, 25, 27. Pretty sure it's at an x value of 27. And a y value of 12. There's the center. Now that means that those 2 points are at 28, 12 and 26, 12. I only need one of them though, so that's all I care about. Now, the way I drew my little hyperbola, I know 2 other points on it. I know there's a point at 28, and we got what? 14, 16, 18, 20. And this point down here, which I'll need when I start trying to restrict the drawing, possibly. I'm going to take away, well, if my tree has true symmetry, but we'll see. That's one of the things when you do these, you've got to be symmetrical. I may just have to erase this video and start over, to be honest with you. That's 3, 6, 8, 3, 6, 8. Oh, I did pretty good. So this is going to be at 4, 28, 4. Now I'm going to write an equation for my hyperbola here. This hyperbola is opening left to right. And hyperbola is this little distance right here is always a. So a is 1. And the form is going to be x minus h all squared plus y minus k all squared equal to 1. And because it's parallel with the x-axis, you could think about this having symmetry over the x-axis. Because of the way its symmetry is, I'm going to put that 1 squared under that guy. Now, we're going to have to figure out what b is. We don't know what b is. We're not going to use foci to do such a thing. What we're going to do is we're going to plug in points, okay? This center here is at 27, 12. There's my h and there's my k. And I actually made a mistake. Sorry. This is a point on the parabola, and so is this, okay? And I actually made a mistake when I plotted this point. It's 2 units to the right, isn't it? It's actually at 29, 20, 29, 4. But this is going to give me an x value and a y value. Now I'm just going to plug those things in. So I'll have for x 29 minus h 27, all squared, sitting over a 1. Plugging in for y, 20 minus 12, all squared, sitting over b squared, and that equals 1. Then I just do the math that I can. 29 minus 27 is 2. 2 squared is 4. 4 over 1 still 4. 20 minus 12 is 8. 8 squared is 64. So that's sitting over a b squared, and that must be equal to 1. Well, that wasn't too bad. What I'm going to do is I'm going to multiply by the LCD. I'm going to b squared every single thing. And that'll give me 4b squared plus 64 equal to b squared. And this is just a simple b's on one side, numbers on the other. Interesting enough, something seems incredibly wrong, doesn't it? You know why something's wrong? Because this is a hyperbola, and that is a minus sign, not a plus sign. I need to wake up and do my job right. If you wonder why I knew something was wrong there, it's because I was about to have an imaginary b value, but that fixes it. So anyways, I'm going to move b squared over here. That's 3b squared. When you jump a negative 64 over, it becomes positive. And we'll divide out the 3. So b squared is 64 over 3. And there's honestly no reason to figure out what that is. I mean, you just plug it into the equation. All right, so the actual equation for my hyperbola is x minus 27 all squared, sitting over 1 squared, which is 1, plus y minus 12 all squared, sitting over 64 thirds, and that equals 1. There's the equation of my hyperbola. Now I'm going to go to Desmos, and I'm going to graph this thing. That's my next step. Go to Desmos and graph it. I wish that I could keep this in the forefront for you off to the side, and there probably is a way to do it, but I don't know it. So what I'm doing here is I'm going to glance at that piece of paper and see what things are. Not trying to throw you off, just I'm looking at that piece of paper and I don't know how to keep this locked up at the same time. In the older versions of Windows, you could do what was called a dock, but I don't think Windows 10 allows you to do that. So it just kind of has to disappear from sight. The equation that I wrote was x minus 27 all squared, sitting over 1, you can show that if you want, plus y minus 12 all squared. That guy was sitting over 64 thirds. And I put plus, and plus isn't right, is it? Did it again. Hyperbola is about minus, and that equals 1. So that hyperbola, I'm going to have to go quite a bit to the right and up to see it, is right there. Now this doesn't look exactly like what you drew on a piece of paper. Okay, it doesn't, because it's a true hyperbola. Not much we can do about that. There's really not. Let's kind of look and make sure some things are right here. On paper, I had an intersection of 2920. "22, 24, 26, 28. There's 29. There's 20. So it lined up pretty good, didn't it? It did. What I have to do is I have to do some restrictions on this hyperbola. I only want the tree to be drawn. If you look back at my piece of paper over here, for a low value, a low y value of 4 to a high value y value of 20. Now you can also control this through domain too. The hyperbola can be controlled many, many different ways. But I'm just going to do a restriction on y. I think that'll do the job. So I'm going to say the low y value is 4 if I'm looking back at my graph, which is what I'm doing. And there's my tree trunk. That wasn't so hard, and you got to use a hyperbola. All right, now let's go back over and look at some other things on this tree. Maybe let's try and draw, really not the leaves, I did like a 3-year-old's version of a tree here. We can add more detail to it later always. But let's do something, maybe do part of it as a circle. You know, a lot of these things you could think of as circles. Like this guy right here, I haven't taught you how to draw a sideways parabola yet, but he looks like a pretty good circle to me. He really, really does look like a good circle. Placement's not the best. You know, it doesn't have a very good center. Doesn't have a very good radius either, so maybe I won't do that. But if you're very careful when you do your drawing, you might be able to incorporate parts of a circle on this. The problem I really don't want to do as a circle is because it's going to have to line up with this, and those aren't at good points. They're really not. They're really, really not. So Mr. Milbrath should have thought about this a little better when he drew. But anyways, you pick better points than I did, and you'll be all right. To truly draw this tree on Desmos, you're going to have these things intersecting at nice, good points. Nice points. This one's not too bad. The problem is it's a sideways parabola. But anyways, let's view this as part of a circle. Now, where is this at? This guy has an x value of 25.5 for its center. And a y value of about 28.5. Its radius, it's not a perfect circle. It's 2.5 over here. And that's what I'm going to have to go with. Its radius is 2.5. So its equation is going to be x minus 25.5 all squared plus y minus 28.5 all squared, and that's going to be equal to 2.5 all squared, which I believe is 6.25. But anyways, let's think about drawing here. I'd like to have this thing drawn from there to there. Okay? Actually, that's not entirely true. I'm going to have to throw some of this stuff away. So I'm only drawing half this circle here. I'm going to have to actually do a restriction on x and y. See, the x values that I want are to draw between 23 and this guy right here. Is it 27? 30. So I want to draw x values between 23 and 27. And we'll do that and we'll kind of see how it lines up. And we're probably going to draw this parabola as well. Okay? That's going to be a little trickier. It really is. We'll use Desmos to kind of help us with that one. We will. So it'll be okay. X minus 25.5 to the second plus y minus 28.5 to the second. And that's equal to that 2.5 squared, which is 6.25 when you do the math. Now remember I was talking about only keeping part of the circle. That's all I really want is part of the circle. Desmos gave me some points here that are worth having, like this high value here, this 25.5 and 31. I'm flipping over here because I realize I need it now. And I'm just going to go ahead and label that point. That was 25.5, 31. And things start getting, kind of cluttered here. They really do. So you might do that on a separate piece of paper. I'm just doing it so you can see it on the same grid that I'm drawing on. Now what I'm going to start off with is controlling x, 23 to 27, and see what happens. I don't think it'll do the job. It shouldn't. But I'm going to restrict x to be between 23 and 27. And yeah, see, it didn't restrict it like I needed it to. This one actually needs a restriction on y as well. So let me flip over to my diagram here. I need to know the coordinates of this point. I do. And the problem is this is not a well-placed circle. So mathematically, it's actually kind of difficult to get that point. But we'll make it work. Okay, we will. but I'm going to restrict y from here to 30. Now, if I just look at my piece of paper, that'd be 28, 26. So I'm going to restrict the y values to be between 26 and 30. Well, that didn't do what I wanted it to do, did it? Not at all. I really thought that would have done it. But it did not. And why would it? So the circle's kind of hard, isn't it? It really is. I've got the 23 to 27 on X. I don't see a problem with that. And if you restrict the Y, well, that's just throwing me off here. I really would have thought the restriction on Y would have done that because that's basically a semicircle. What do I have here? 26 less than or equal to Y less than or equal to 30. Oh, because I'm being stupid, kids. I do this every once in a while. The high Y value of what I wanted drawn was right there, 31, the top of the circle. So there's my problem. Just having a senior moment. But I still didn't get to throw away what I wanted to throw away, did I? Still drawing too much stuff. Way too much stuff. Way too much stuff is being drawn. I'll put in for X. Put in 23, which is reasonable. Nope, the circle got me stumped a little bit. Well, here's what I'm going to do. I'm going to actually do the circle twice, and this is pretty common with circles. What I'm going to do is I'm going to draw this part of the circle, okay? And then I'm going to draw this part separately. So I'm actually going to have to put in two equations to get the circle, and it happens. I'm going to restrict this with X and Y. I'm going to have X values between 23 and 27, just like I have. And the Y value is going to be stuck between 28.5 and 31 up here. So 23 to 27 on X. And the Y value, I done forgot what it was, to be honest with you. 28.5 to 31. So that draws the top part of the circle. Now I'm going to have to draw the bottom half of the circle, and I just deleted it, but thankfully there's an undo button. So I'm going to type in the original equation again. And I'm going to start throwing stuff away. So I completely overlapped. Now, if we look back at my piece of paper here, the X values that I care about are from here to here. All right, here to here. Here's an X value of 23. And then there's this X value. That's 25, 24, 23. Well, I guess that's a 22. That's 23. This must be at 24. So x values between 23 and 24 are going to be drawn. And there we go. There's that. Now what I'm going to do is I'm going to draw the parabola, or write an equation for the parabola underneath. Now, a big thing I just did here was I kind of arbitrarily assigned that thing to have a value or coordinate of 23, 28, 27, 26. I'm going to draw this little parabola, and it could also be done as a half circle if you want to do it as a half circle, but I need parabolas in my tree. I mean, that's just something else I got to have. So this parabola that I'm looking at, you like this angle I got? I'm leaning over, chin's all down, should be a good angle. 4, 8, 12, 16, 22. There's a vertex with an x value of 22. 4, 8, 12, 16, 20, 21, 22. 24. I'm going to write an equation for that thing. It's not hard to do. Sideways parabolas, they square y. Y minus k squared is 4p, x minus h. And the vertex gives me h and k. So y minus 24 all squared must be 4p, x minus 22. Now, this point right here gave me an x and a y, so I'm going to plug it in. Y looks like 26, so 26 minus 24 all squared is 4p. 23 minus 22. You just do the math. 26 minus 24 is 2. 2 squared is 4. And this is 1. We end up with a p-value of exactly 1. So I can actually come up with an equation. When I type it in Desmos, I will take that 1 and I will stick it there. That's what I will do. And I'm going to use Desmos to kind of help me figure out the restrictions from here on this one. So we have a y minus a 24 to the second power. That's equal to 4 times x minus 22. Just glance at my piece of paper. Now, how much of this parabola should I draw? That's the real question. Notice it gave me a nice intersection right there. I'm going to just do a restriction on the x-axis here. I'm going to restrict the x values to be between 22 and 23.79. Congratulations, you got part of a hyperbola. Now, I'm of the personal opinion here that that hyperbola is just a little too tall. And I also notice that I don't have a very perfect circle up there. But it's okay, you're coloring, right? Like that would be part of it. You might throw away part of this hyperbola. You could do a restriction on y, just draw it from maybe here to here. It might look a little better. It might. But that's kind of how you can interact some shapes together. We did a semicircle, we did a hyperbola, we did a parabola, and that's kind of how you would draw a tree. Now, when you start drawing a tree, do something that I didn't do. I just drew a tree. I didn't think about things being at nice points. if you draw it so that everything lines up nicely on your graph, it's going to be a lot easier to write the equations and restrictions for Desmos. So anyways, there's just a little video for you. Hope it helps you. Hope it gives you some ideas. Hope you watched it. You didn't have to, but I hope you did. Have a good day.